Welcome to another edition of Our City. The beginning segment, as always, talks about a schedule of events going on in the city of Elizabeth. This week, I am a delegate for Senator Hillary Clinton in Pennsylvania at the National Convention. So as far as a public schedule, that's not happening this week. But you can visit www.elizabethnj.org or any of our social media sites to look for any event editions that may happen during the week. So if you need any information of these events, please call our Public Information Office at 908-820-4124. And please stay with us after these brief messages, where I'm going to be joined by U.S. Coast Guard and a postdoctoral research associate. It's going to be an interesting show.
Sometimes you learn by helping others learn. Kean University.
This show this evening is dedicated to the guests we'll be discussing the pending season of storms and the potential hurricanes. So I'd like to welcome you all back for a very interesting show. I'm pleased to be joined by Mr. Owen G. Earle, who is a U.S. Coast Guard cutter Wire. Owen, welcome to the show.
How you doing, Mr. Mayor?
And Dr. Kiran Bhatia, a postdoctoral research associate.
Yeah, thank you very much. Thank you very much for being here.
So, Kiran, why don't you introduce yourself first and your role at NOAA's Geophysical Fluid Dynamics Laboratory. Before the show, I said, that's a mouthful.
Yeah, it is a mouthful. I think for the rest of the show, we call it GFDL. I was born in the D.C. area, grew up in Silver Spring, Maryland, and went to University of Maryland studying physics. I then went to University of Miami, and that's when I got interested in hurricanes. Got my PhD from there, and then this March I started at GFDL. There I'm going to be looking at how hurricanes will be with climate change and how the future of the impacts will be different than today.
How do you do that? I mean, you got to project to the future, I would imagine.
Exactly. Yeah, you're going to be looking at the future, and lucky for us, we think that the physics and the dynamics that are happening today will be very similar. The same equations will be solved then. So we think our projections, will be accurate as they are now in the future.
So where are your offices now that you're up here?
Yeah, so my offices are in Princeton. It's the Forrestal campus. And I should mention that all my thoughts and comments today are my own and not the NOAA GFDL labs.
Yeah, make sure you get that disclaimer out, because otherwise people will be calling and saying, hey, this is the opinion of the organization?
Yeah.
Yeah, good point. Owen, your role in the Coast Guard, introduce where you're from and how'd you grow up?
Absolutely, sir. I'm originally from West Milford, New Jersey. I've been in the Coast Guard for 14 years, and currently I'm stationed up in Saugerties, New York. I'm on board the U.S. Coast Guard cutter Wire. I'm the executive petty officer on board, so I'm second in command. And I've been here locally in the area for 2 years. This is actually the first time in 14 years that I've actually been stationed anywhere close to home.
So where are you actually stationed?
In Saugerties, which is probably, if you go up 87 towards Albany, about 2 hours north of the city, up 87.
So it's on the Hudson?
Yes, sir.
Okay. And you live up that way?
Yes.
Okay. So, well, thank you for coming, both of you, for coming on the show. It's a bit of a hike for both of you. We do appreciate it. Explaining to us. So, have you always wanted to be in the Coast Guard? When did the light bulb go off and say, yeah, I'm going to join the Coast Guard?
Light bulb went off actually when I was living in West Milford right after the events of 9/11. I had joined the Coast Guard Auxiliary, which is the volunteer organization that was in New Jersey and bordered New York and New Jersey on Greenwood Lake. And I worked with them for about a year and a half, and then I joined up with the regular Coast Guard right after that. So it's kind of after the events of 9/11, seeing the effects that it had on the country and family and friends local to the area kind of gave me the push. So when I talked to my father and I said that I wanted to join the military, he said, okay, you can look at all of them but the Marines. He was prior Marine Corps.
He was a Marine.
Yes.
So he didn't want you going.
Yes, sir.
So all the Marines watching the show are going to say, how come that kid didn't go in the Marines?
That's all right. Right now, my girlfriend's father's a Marine, so I get enough from him. It's
you
good.
get enough from him, right?
Yes, sir.
So you're studying, and what made you go into that field?
Yeah.
You didn't wake up one morning and say, I'm going to study hurricanes.
No, not exactly. I actually, when I was in 6th grade, my teacher at the time always had a radar in the back of the class. And for me, it was just, I realized that all the sports that I played, all my activities after school were centered around these colors showing up on the radar. So I wanted to be able to forecast it. I wanted to understand why they happened, why the storms happened. And after that, that was the start of a long journey of, trying to understand the weather.
So tell me, why does a storm happen?
There's not enough time for this show, but that's a long story. We can't even get into that right now.
Why a storm happens?
Yeah, why a storm happens? Well, I mean, I would say storms happen, and all weather is kind of driven by the temperature differences between the equator and the pole. That's the starting point. And then after that, it's a lot of horizontal differences between temperature, a lot of where does the rising air happen. Yeah, we can go into all kinds of details.
So why do storms not happen then?
Why do storms not happen? Well, when air doesn't rise, or when air is not more buoyant than the surrounding environment, then you're not going to have cloud formation. You can also have not enough what we call condensation nuclei for the clouds to form on. There's a lot of reasons. Sinking air, that's another reason why storms don't happen. And there's certain locations, there's we call it the around 30 degrees north, all that around the whole globe in the north and southern hemisphere. That's a lot of areas of sinking air because of global circulation patterns. So those are where the deserts are typically, and that's one reason right there why storms just don't happen in those regions.
Because you have the deserts, right?
Yeah.
And if you had a lot of storms there'd be some type of vegetation.
Yep, and and the global circulation patterns have a large area of sinking air there, so that you don't have a lot of cloud formation.
So, when you're in a desert, you see this one piece of grass or one weed growing.
Yeah.
How does that happen?
Well, that's what we call resiliency of vegetation. Some of these plants, it's survival of the fittest, and they learn to accommodate what the situation is, in their particular climate. And they're more resilient than the grass around it, and they actually selectively form in these locations.
So, Kieran, tell me about the difference between a significant storm and a hurricane.
Sure, yeah. So significant storms are, like nor'easters, thunderstorms, maybe an extratropical storm like Sandy. It's all has to do with where they get their energy from. So with Sandy and things like nor'easters, they're getting their energies, Sandy's a little bit different, but they're getting their energy from the temperature differences that exist in the atmosphere, and that's normally horizontally. Whereas a hurricane, they get their energy from the ocean water. That's their fuel source. And as a result,
So you don't see hurricanes in the middle of the country then?
No, you don't. Yeah, the formation of hurricanes don't occur, it happens over the ocean for a reason. And what that energy source does is the fact we have a lot of fronts around these low pressure centers like nor'easters that aren't hurricanes because of these temperature differences. They're separating the different warm and cold air. But with a hurricane, it's almost completely uniform, the temperature around it. And that's actually part of that structure is what causes the stronger winds of a hurricane to be close to the center. But with a nor'easter, it's like a very large swath of the same wind speeds. Now, the final thing is with a hurricane, the naming is such that if you are a hurricane, you have to be above 74 miles per hour, right? So that's immediately, you have a speed that you're above. So you know that hurricanes are going to be pretty intense. Where nor'easters, you can reach that speed, and with things like Sandy, you can reach that speed, but it's not necessarily always going to happen. So I would say the worst case scenario for these hurricanes are a lot higher, a lot worse than what we have with the significant storms like nor'easters.
And you have categories, right?
Exactly, you have categories. The Saffir-Simpson scale is what we have the different cutoffs for the categories.
So you're in a vessel, and he just talked about the difference between significant storms and hurricanes. On the vessel, if you're out of the water, what do you do for a significant storm? What would you do for a hurricane? What's the big difference for somebody like you?
For somebody like us, when you're looking at us as a Coast Guard, we actually have to do storm aversion where we actually will move away from wherever the storms are. So we may take all of our vessels, and if we know a significant storm's coming in, we're actually going to move our vessels maybe farther inland, or we may try to go offshore and then try to ride them out offshore, maybe farther north if the storm's coming from the south or things of that nature. For anybody that's personal watercraft out there in their private vessels, The biggest thing that we recommend is that if you ever see any type of bad weather come in, if you get those news reports early, we try to broadcast that as a Coast Guard as soon as possible. Whenever we have significant storm information coming up, we'll put that over the radio, and then there's also a weather channel that you can listen to via the VHF radios that they have on board their boats. The biggest thing is finding safety at that point. Getting your boat into some place, into land, to where you at least can get off the boat yourself. You secure it up best as possible, but at that point, sometimes we know that you just have to remember your life is more important than that of your boats.
So, do people listen to the radio when they're out there? I mean, or they should, right?
They should, yes.
But
yes.
some just turn it off.
Some turn it off, maybe they have it on low. It's one of those things that it's not necessarily required, but again, we always try to push the safest practices. And it's also having the radio for yourself, but also being there for your fellow mariner as well, because you could be out there enjoying time with your family and you receive a call from somebody that's maybe 100 yards away from you and their boat's sinking or they need help, and you could possibly be the first one over there to help them out. Because when you're out there in the ocean, a lot of times it doesn't matter if it's an actual Coast Guard vessel coming out to save you. Just seeing another boat could be better than nothing.
Do boats travel further than they should? Pleasure boats, pleasure craft?
No, I wouldn't say that. I think the biggest thing people need to realize is understand what their comfort factors are and understand severities of what may happen if they go out. So if you're a new boater and you take your boat, say, 30 miles offshore, there's some things you may want to get down first as far as driving, making sure your safety equipment is proper, and making sure you're comfortable before you start making those large trips, farther offshore. But there's seasoned mariners that will go up and down the coast and take their vessels all over the world. It's just a matter of your comfort level.
So Kieran, tell us about those differences you're just talking about between the city and the region. How do they impact not only an urban area, but also the region as a whole?
Yeah, so the first thing I have to mention is that nor'easters and other significant storms, they happen much more frequently here. But again, the speed limit...
Do they happen more frequently on the East Coast than they do the West Coast?
Yes, they do, yeah. It's a completely different dynamics as far as what the weather that form on this coast versus that coast, yeah. So the nor'easters are definitely an exclusive thing to this coast. But the issue as far as the region is the speed limit, again, with these hurricanes is much higher in the worst case scenario. So a lot of times you'll see that you will have similar impacts for the weaker hurricanes. But of course, this region, once you have, the category 3s, 4, and 5s, which we haven't had recently, although we have had Irene and Sandy in the last 5 years, those kind of concerns are much higher that are associated with those storms versus the nor'easters and the storms like Sandy, as well as some of just your average summer thunderstorm.
Is Sandy a 100-year storm in this area, or can that be repeated?
Sandy can definitely be repeated, and it is a rare storm because of the way it was enhanced by other weather. You had a front coming in at the same time as a hurricane weakening, which actually turned it into a much stronger storm. But of course, you have other hurricanes like Category 4 and 5 hurricanes, which have not hit this area recently, and in the longer records, you can see that they have. So those are some return periods that we also need to worry about for those stronger storms.
So in the Coast Guard, do you prepare locally for the differences that Kieran's talking about? Will you do something different in the Elizabeth Newark area in the water as you would in, say, Manhattan or further up the coast, the Hudson River or something?
So for this area, our main hub is going to be Sector New York, right on Staten Island. That's where the captain of the port is, and that's where all the major department heads that organize all the units around the area come together and start working with local municipalities and everything like that. Basically, once we start getting word of any type of storm formation, whether it be a hurricane or even if it's going to be a major event like a nor'easter where we might see a lot of damage, Coast Guard starts their preparations way in advance. So this is where we start looking. So for me locally at my unit, I'm going to start getting people back in that are maybe on leave or on liberty or something. And we're going to prepare because as soon as we get the call from our sector that we need to go out and respond to maybe the Elizabeth area or to Manhattan area, we're going to have assets ready to go. Our time frame that we want to have everything at 100% capacity, that we're ready to go wherever, is within anywhere around 96 hours. Is what we want to be prepared for, that any assets can deploy any place with full support to that local area.
But you don't, at some point in the storm, you're not even out on the water, right?
That's what we try to get away from, absolutely. However, there are units and there are areas where sometimes Coast Guard men and women have to answer that call, and they may be out during those storms, whether it be via aircraft or via vessel. So there are those times, but that's again where we try to put out as much information as possible to help people get back into port and get to safety as soon as possible. But sometimes you just don't have that.
But sometimes, as a doctor, you wouldn't recommend, right?
No, yes.
Based on what you would know from a theory point of view, you'd recommend some of these boats stay in.
No, yeah, boats aren't meant to deal with 15 feet of surge, winds at over 150 miles an hour. Of course not. So yeah, that's definitely concerning for me to hear that.
Right.
That's part of the job description, but I guess it is what it is. I mean,
I'm going to run a couple of commercials, come back and talk more about this. Extremely interesting. Please stay with us after these messages, back with more about preparing for storms and how they form here in our region.
We're an American original, dependable, historic, nuanced, with all the comforts of home, even when you're just visiting. So we're celebrating for all that we've left untouched and all that we've changed. A place where the past meets the future. So consider this your invitation.
We've been celebrating here in Elizabeth for 350 years, and we're just getting started. Welcome back to our city. So Kieran, one of the questions I think a lot of people have is when, like Owen was talking about, they have to prepare 96 hours before they're ready to go. So the average citizen has to prepare by watching TV, basically, and they see all of these different models.
Yeah.
And so what's Joe Sixpack to believe? How do these models get created, and what are we supposed to believe?
Yeah. So the model they take
Very challenging, by the way, where you see all these lines.
Yeah. No. Yeah. Those are called spaghetti diagrams, and they are very hard for people to to ingest these crazy looking diagrams. Yeah. So. All models start with the initial conditions, basically what is it outside right now. And of course, we can't observe every piece of the atmosphere, every square inch. So we have to make approximations there, to kind of get the whole grid, the whole map of the world. And then what we have the model equations, solving the equations of the atmosphere, telling us how it's going to be in the future. And again, because even though we have the best computer models and computer systems in the world dedicated to meteorology, we can only solve these equations so well. We have to approximate it because of the time constraints. So that is another little element of error. Now, as a result, that third step of when you see the diagram with lots of different solutions, those little approximations that every modeling center in the world make by themselves, and they have their own ideas of what should be done, those actually cause the variations in track and in intensity and wind speed. So what happens then is the National Hurricane Center, they take those spaghetti diagrams, those different model plots, and they go ahead and they come up with a cone or a most likely solution. And those images, those final images of where the storm is going based on what the National Hurricane Center forecaster says, those are some things that you really should look at, because the diagrams, some of those models in those diagrams are better performing, some are not as good at certain things, at certain situations, and it's really good to see that final all-inclusive cone diagram, I would say.
So Owen, you were talking about preparation and 96 hours out and the procedures that you have to do, and how do you prepare for the local impact storms based on what Kieran was just saying with all these different models? Do you guys got to guess, what's your best educated guess when you see all these different models?
So this is where coming together with our local partners and then working very closely with National Weather Service and all of our other assets that we have, we try to figure what is the most likely scenario that's going to happen. And honestly, there may be times where we may have a couple different likely scenarios, so that's what we're going to plan for, and that's really where the captain of the port comes in from Sector New York. And him, along with the department heads, we start organizing and saying, okay, we want to have a certain amount of assets that will be ready to respond to this area. These assets will respond to this area. And that's where that preparation out 96 hours, that's where that comes into play, because now we have our organized of, okay, you guys will take care of this area of responsibility if this happens. And then what we do is, as it gets closer, we're constantly reevaluating. So this becomes anywhere from an hourly to every half an hour. We try to get as much updated information as possible. So it goes from this large area that we look at and we're prepared for, down to, as the storm gets closer and closer, we have people manning the radios, we have people in the comms rooms and ready to assist when the call comes out, that it gets very narrowed down to where now we can reorganize what our structure is going to be.
So, do weathermen purposely scare the hell out of us? I mean, after Sandy, most people, we watch and we're, doomsday, and then, it's not going to happen. We get the attitude now, after listening to some of these folks. What do you think?
Yeah, it's not in the job description at all.
It's not in the job description.
It's not. I'm going to take some of the blame off the weathermen and put it on the media, because what we have now is a lot of Facebook forecasters and some people who are not as qualified to be coming up with these, massive predictions. They have maybe 1 million or a couple million followers on some social media site, and that's where you get, a lot of the hype. But if you go ahead and look at maybe the National Hurricane Center website and say, okay, what is, they have these diagrams, what is the percent chance that we'll have above a certain wind speed, for example? That's a diagram they have. Even with Hurricane Joaquin last year, they had it 5 days out, and I know there were some cancellations of.
It never happened.
It never happened.
Not for us, anyway.
Yeah, not for New Jersey. But if you looked at some of the diagrams they had online, you could see that the National Hurricane Center had a 5% or a 1% chance of wind speeds above 35 miles an hour here or 50 miles an hour here.
Well, there were some people during that storm predicting that it was going to be as severe as Sandy.
Yeah, exactly.
They were saying, and it basically scaring the hell out of people.
Yeah, so a lot of people don't understand the uncertainty at those 5-day periods, and they see it as part of the cone or as part of one of those lines, and they think that 5 days out we know it just as well as we know it 3 days out. Well, to be honest, the errors for track and intensity almost double, going from 3 to 5 days. So you gotta know, the uncertainty, know the errors before you make those decisions and overhype, what these storms could be.
So we've talked a lot with the both of you about preparation. What do you do, Kieran, after the storm?
Okay, so after the storm,
Do you just fall back exhausted? No.
no. So the first thing, well, first of all, my agency in general and where I work, we're going and saying, okay, why did the models perform the way they did? Why did they do very well? Why did they do very bad? What was going on with this particular storm? And then second of all, we want to know exactly how did this storm develop? How did it decay? What was going on with the dynamics of the storm? What happened? We're digesting all that information. The final thing we like to remind people is, and especially with high storm surge and high storm surge impact areas like Elizabeth, that even though the storm or the hurricane might be gone for 12 hours, hurricane conditions can still persist, especially with flooding. So it's not race back and go back to our homes if we evacuated. It still takes a while for the waters to recede. The next high tide could be dangerous. And I'm sure Owen could talk more about that. I mean, it's definitely a concern even after the storm has passed.
Yeah, that's my follow-up question.
Okay, great.
After you is, what do you do after the storm?
So we do what's called post-storm assessment. And one of the first things that we do is we go into the area, and one thing may be if there's any type of aids to navigation out there in the river. We're going to assess all the channels. We're going to make sure buoys are in the right spot. We're going to make sure that it's safe for any boats to actually be navigating on the waterways.
Because that could move during a storm, right?
Yes, sir.
And it could
Absolutely.
hinder traffic where people could run aground or something.
Yes, absolutely.
Okay.
And then you have different parts of the area as well where you may have the entire channel will actually shift. So the buoys and the aids to navigation may be in the right spot. However, you have shifting sandbars, you have, the entire channel can move, X amount of yards south, and nobody would ever know, and if they follow the markers, they're going to run aground. So that's one aspect that we do. The other side of it is, this is where, again, we work with local partners, and we see, okay, who needs our assistance? Do they need our boats? Is there areas that are flooded that they need us to come and help them get into certain areas? Because we're going to pull our assets, and we have, you know, shallow watercraft that we could possibly get a hold of, or we may just have personnel that if the local fire department says, hey, we need people to help us get, you know, people out of certain areas, we're going to go in and assist them that way. So this is where it really becomes that joint team of working with power companies, gas companies, PDs, FDs, you know, trying to get everything together and safe for people to actually come back in. And that's one of the largest things we stress is people are in such a rush to get back to their homes, and we try to let them know that, you know, please hold off because you may not see it, but we're working very diligently to make sure it's safe for you to get back to your home and to get back there and do your own post-storm, you know, cleanups and everything
And
else.
you're never fast enough, right, for the homeowner? I mean, right?
We do the best that we can.
Of course you do, but I'm
Yes,
saying
sir.
the homeowner never thinks it's quick enough, right?
Yes.
That's a struggle.
It is. It's a definite struggle, and that's where, you know, I applaud every one of the men and women that we work with, that their patience is phenomenal when it comes to dealing with the public, because not only being in the Coast Guard and having to deal with the people, but I've been in the situations as well where I've lived in areas and been stationed in areas where I went through the hurricane not as a Coast Guardsman, but even just as a civilian as well. I lost things, or I was worried about my apartment or houses that I lived in. But so we can relate to those feelings. However, at the end of the day, you have to really look at it. What's more important, your life or your property?
Right.
So that's what we try to make sure is safe, to where you can be able to work on both.
So, Kieran, switching gears a little bit, you both talked about data and what you do after. What do you do with the data when you acquire? Do you share it? Do you send it to anybody besides, like, local people that they get it, or is it more mass media type of thing?
Yeah, so my particular lab is not in it's not in charge of, you know, making the operational calls, to my knowledge. There is a GFDL has a model that runs during the storm and comes up with forecasts for intensity as well as the track. So that's there. But during the storm, you know, we're answering questions to media if needed, taking, you know, all the questions that we can. But we're not sharing data. It's not our role as a laboratory to do that.
Okay.
Yeah.
So, but if the Coast Guard called and asked you questions, you would
Oh yeah.
give the answers, in other words.
Yeah, yeah.
Based on the data and the research.
Exactly. Yeah.
Okay. Couple of questions before we wrap it up. Businesses and residents prepare for a storm. Can they call the Coast Guard and ask for advice? Is there a public information stuff they do?
There absolutely is. You can look online, and we try to post information up. The biggest thing when it comes down to hurricane preparation, and this is what we'll even pass from our watch stations and everything, is number one, have a plan. Know what's going to happen. If you have to evacuate, where are you going to go? What are you going to do? Number two, having resources ready for you. So bottled water, canned foods. Also, we recommend even having some money saved aside, put over to the side. This way, if you do need to evacuate, if you need to get a hotel or something, you know, we can't tell you whether it's going to be a couple days before you can get back to your home, or it may be a week. As a good rule of thumb, when you're setting up your hurricane preparation kit, try to plan for about a week's worth of food and water at a minimum, because that should be able to sustain you, and hopefully by then we can get workers in to get power reestablished, get water, gas, everything turned back on.
Well, during Sandy, I had 11 days without electricity. Mm-hmm. So I called the power company and I said, do me a favor, since I'm the mayor, make sure my power's turned on last. So otherwise, I'm going to wind up getting a lot of calls on why my power is on. You know, you two guys have been really educational and instructional for not only me, but for the guests who watch this show. And I thank you for taking the time to join us here this evening, and I appreciate all the work that you do. Thank you very much.
Thank you, Mr. Mayor.
Thank you.
For Dr. Kieran Bhatia and Owen G. Earl, I'm Chris Bolwage, and we'll see you next week on another edition of Our City.
We're creating tomorrow's jobs today. Kane University.